We're now going to look at metal hydroxide decompositions, and the general formula for metal hydroxide decomposition is MOH gives MO plus H2O. Alright, so we've got all of these metals here. We've got charges from 1 to 6, and I'm going to show you how you can get the charges on each of them. Actually, as a general rule, it's fairly easy to figure out what the charge on the metal is. If you know that OH has a -1 charge, then the metal will just have to have the opposing positive charge for how many hydroxides you've got connected to it. So if you've got 2 OHs, that's -2, which makes this +2. 3 OHs, -3, that's +3. 4 OHs, -4, that's +4. 5 OHs, -5, that's +5. 6 OHs, -6, that means it must be +6. Right, so that makes it fairly easy to get the charges there. So let's see how this works out. First thing we want to do is write down what a pattern is. So it's NaOH gives NaO plus H2O. And what we're looking at here is, so we've got heat here as well, of course, is we're going to go ahead and put the charge on the metal, which we've already decided is going to be +1. Oxygen is going to be -2. Go ahead and write the formula of the metal oxide, which is going to be Na2O. We need 2 sodiums to match charge on the oxygen, plus H2O. And then we need to balance this out, so we've got 2 sodiums here. I put a 2 in front of this one. That gives us 2 oxygens, and so that would be 1, 2, and we've got 2 hydrogens. That's 1, 2. So now that one's balanced. Alright, let's look at the next one. We've got CaOH2. Again, we do the pattern here, Ca and O, and that's going to be 2 plus, and that's going to be -2. CaOH2 gives CaO, so these balance out, the 2 plus and the 2 minus. It's H2O. And again, we try and balance it. We've got the Ca, we've got the Ca, we've got 2 oxygens, we've got 2 oxygens, we've got 2 hydrogens and 2 hydrogens, so that's balanced. Let's look at the next one, AlOH3. Al and O plus H2O. Aluminum is 3 plus and 2 minus. Remember, the charge is going to be the opposite to the number of hydroxides we have. So if we've got 3 OHs, that's -3, which makes that +3. And that would be Al2O3 plus H2O. And -6, 2 times +3 is +6. So that evens out there. Alright, so now we can take a look at the balancing. And this one, we've got 2 aluminums here, so I'll put a 2 in front of this. That means now we've got a total of 6 oxygens, because there's 3 here and we've got 2 AlOH3, so that's a total of 6. Which means we've got 3 here, so I'll put a 3 in front of that. Looking at the hydrogens, we've got 6 hydrogens. 3 times 2 is 6. And again, the oxygens, 3 plus 3 is 6. And aluminums are 2, so that one's balanced as well. Let's look at the next one. This is the lead. We've already decided that lead has a +4 charge here, -2. And this would be PbO2. And again, we've got -2 and +4, which means we need 2 of these to balance out the +4. And looking at the balancing here, we've got 1 lead and 1 lead. we've got 4 oxygens and 4 hydrogens, which means if I put a 2 in front of here, we're going to balance out the hydrogens to 4, and now the oxygens will have 4. That's 2 plus 2 is 4. Alright, so the antimony, we do the same thing. We've got -5, +5. Sb2O5 plus H2O. And we've got, let's see, we've got 2 antimonies here, so I'll put a 2 in front of here. And now we've got a total of 10 oxygens and 10 hydrogens. And I put a 5 in front of here, that gives me 10 hydrogens. 5 oxygens plus 5 oxygens is 10, so that balances out as well. Okay, the next one. MO is +6, O is -2, and the formula would be MOO3, that's -2 is times 3 is -6, and +6, so we need 3 oxygens to balance out the MO. And looking at the balancing here, we've got 6 hydrogens, and over here we've got 2, so I'll put a 3 in front of here. And now we've got 3 oxygens plus 3 oxygens, that's 6, so that balances out. MO is 1, and that balances out as well.